review slopes briefly, right? So I give you a bit of a map at the beginning, right? What is slope going to be used for? Well, it turns out slope will be extremely important for pretty much everything we do when it comes to graphing, finding points, and so forth. It's the same thing as the rate of change, but slope is usually used when there is no context around it. Morning, Mark. There's no context around it, then we rather refer to it as slope. But if you ever do call it rate of change, don't be afraid. It's the same thing. The letter that we associate with slope is M. Don't ask me why. I guess the S just wouldn't do well, right? We'd confuse it with a 5. I don't know. So slope is there. Probably different language. That's why. It tells us the steepness of the line. So whether it's going to be very steep or shallower, right? Less steep. It allows us to find more points on the graph. It stays constant regardless of which 2 points you pick, right? If it's a straight line, it should be the same no matter which 2 points you pick. It can be calculated this way. So this is the way we calculate it. If I'm asking you to calculate it, it will tell us if lines are parallel or perpendicular. The slope not only tells us about the steepness of the line, it will also tell us if it's going to be increasing towards the right, decreasing towards the right. A zero slope is a horizontal. Make sure you remember that, right? A horizontal line has a slope of 0, right? It's not moving. Manitoba has a 0 slope pretty much, right? With some exceptions. And then there's the undefined slope here, and that also was covered in more detail in the notes, right? But if you're calculating, right, this is to calculating, right? This one would be just by observation, the counting method, right? So if you have a graph, if it's given, you can just start at a point and count how many units you're going up and over to go to another point on that line. But make sure it always lands on an intersection if you do that, right? Don't find points that are halfway through a box or something like that. You want intersection to another intersection. So sometimes the best way I recommend is find those 2 points and then count up and over, okay? And then reduce your fraction, because if you pick them far apart, you most likely will get a fraction that needs to be reduced. If they're close together, then it'll be then you won't have to reduce as much, right? And then obviously you have to watch out. If it's going up, then it's positive. If it's going down, then it will be negative. Okay, so we'll talk about that. And so this is where I kind of asked you to stop. Like that was the second video, 6.2, right? And then I told you not to do this part. But there's a second part video that actually goes through this and finishes this page. It's called part 2, okay? And the notes for that one look like this, okay? So I strongly encourage you to do that, especially this part right here. We were checking if the parallelogram is a rectangle, and I go through this and explain how we prove that, how we show that, right? 6.2, I guess what you need to remember is if lines have the same slope, they're parallel, right? They're running alongside each other because they're rising the same amount and they're running the same amount, right? So they'll never meet. So in this particular case, when we observe, we had these 2 lines are parallel and these 2 lines are parallel. So we in fact had a parallelogram, but we did not have a rectangle because you didn't have the negative reciprocal of any slope here. So there are no 90-degree angles happening here. Okay, and so particularly for these questions, you wanted to go to 349 and do 13, 16, and 17. So if you haven't done that, I will do one more example based on a triangle, and then we'll move on to 6.4, okay? And so that's what I asked you to write down just now, okay? All right, here we've got points A, B, C form a triangle. We want to know in particular if this is a right triangle, okay? And so our strategy is going to be, strategy, determine the slope of all three sides. That's basically what I'm going to do. All three segments, right? Segments. Sometimes they're created by lines crossing each other. Sometimes it's just segments, right? Segments are just chunks of lines, and lines are just like they go on indefinitely. So this is my strategy to determine the slope of all three segments, right? So I'm going to start as it's stated. I'm going to find the slope between AB, okay? Between these 2 points connected. So you got to go y2 minus y1 over x2 minus x1. I would not label over here because it's going to get really messy, right? I would keep the ABC just as they are and just kind of do this in your head, right? So just write down the numbers. I'll make B my x2, y2. So I go -4 minus 2. And then I take away the x's. And you got to make sure you do it in the right order. You started with this minus that. Then you got to go 1 minus -3. Okay. And that right there turns into a positive. You got to watch out for the double negatives, okay? So you get -6 over 4. Okay, Alexander, we wrote this down on loose leaf, okay? I don't know if you want to just watch and then catch up later on the video. 2 goes in here 3 times, 2 goes in here 2 times. So -3 over 2 is your reduced slope. So make sure you reduce, okay? Otherwise, you might not catch that you have a negative reciprocal elsewhere. You might not see it. Okay, then I'm going to find the slope. I'm going to stick with A, but I'm going to go A to C. So I'm now dealing with A and C here. And just to make sure I get this right, I make the second letter I use as my second point, okay? So now this is my x2, y2 here. So I'm going to go 1 minus 2 over 7 minus, right? So 7 up here minus -3. There's that double negative again, right? And so 7 plus 3 is 10. So that one obviously you can't reduce any further. So 1 minus 2, and then 7 minus -3. And that's why you get the positive. So that's that. Nothing here, right? They're definitely not the same. And they're definitely not the negative reciprocal of each other, right? So then next I'm going to find the slope between B and C. And so C is my second letter. So I'm going to go 1 minus, right? 1 minus -4. Y2 minus Y1, right? And then it's 7 minus 1. So this is a double negative here. So 1 plus 4 is 5. 7 minus 1 is 8. Sorry, 6. One second here. Right? Over the next couple of days, I will give you more of these where you will actually find negative reciprocals and then determine that it was a right triangle, right? So this you don't need to do on a test, okay? You do not need to write down a perpendicular slope for each, but I just want you to practice, right? So if you have a negative 3 over 2 as your slope, you would be looking for something like this elsewhere, right? If you have a slope of negative 1 over 10, you'd be looking at the negative reciprocal of it. And if you can't find it, then you move on, right? 5 over 6, changing the sign would be negative. Flipping it would be 6 over 5. If you can't find it anywhere, then that's it, right? You do not have any negative reciprocals. Therefore, this is not a right triangle. That's it. Okay. So keep that in mind. And now we're going to move on to the next section in our. So if you can, if you have this in your binder, I would add this handout right after these notes, right? 6.2, right after the homework. If you can take this booklet apart and insert it there, that would be probably the way to go. I'm going to staple this onto my booklet. How's that? If you want to do the same, you can borrow the stapler from me later. Okay, so 6.4 here. If you have a highlighter, I would probably recommend you taking it right now. I'm going to talk about some important concepts here. So there are three forms of the linear equation. This is the slope-intercept form, okay? And I will write this down here. If it's slope-intercept, you're looking at this form. I know it's down here already, but I will write it down one more time so it really sticks, okay? So we're going to go through all three forms, and eventually we're going to ask you to go from one to the other, right? We're going to ask you to convert it and rewrite it. So a lot of arithmetic, right? And so we're going to start with this one. This one is the easiest one to graph. I'll put it over here. Easiest to graph. I'll make note of that, right? And I always like to give a heads up, so I'm gonna maybe use this margin here. So if you ever have y is equal to just a number, right? That's a horizontal line. It would go like this, okay? If you have x is equal to a number, that would be a vertical line. It would have an undefined slope, okay? Remember that. You got to flip through your notes every once in a while and just recap that, right? So if you ever have y is equal to a number, no x, no other variable, it's just a horizontal line. If it's x is equal to a number, it's a vertical line, and that's, so maybe let's add that here. Slope is equal to 0, and here slope is undefined. Sorry, I had to make undefined, right? I just had to make that work. otherwise I'm using up. Okay, so this is something you need to just know. It's a fact, right? Now let's talk about this particular form here. A line is an infinite number of points in a Cartesian plane. It must have arrowheads, right? Arrows on both ends, okay? So that's, if you're just given a line like that, you have to assume that it extends indefinitely on both directions, right? So the y is your dependent variable, just like before. Okay. The x here is the independent variable. Don't forget that. So that stays the same. This is your slope. And also the rate of change. Okay. And this is your y-intercept. Just by looking at that, that value will give you your y-intercept. So you should be thinking of 0, comma, b. Okay? Like this number gives you the y-intercept, and that's where the line crosses the y-axis. Okay, so very important to remember. And so there you have the whole equation. And remember, this is still, there's still domain and range in play, right? You could write this as a function. Remember that? Writing this as a function, you'd be f of x is equal to mx plus b. And so that is all still there, but we're not going to dwell on that too much, okay? So background. So I'm going to basically rephrase everything I just told you here. Y-intercept is given by the value of b, right? Note, if b is equal to 0, it will not show an equation, okay? If b is equal to 0, some students say, oh, there is no y-intercept. Yes, there is, right? It's just not there. It's going to go through 0 here, okay? The x-intercept is found by letting, when you're finding the x-intercept, then you let y equal to 0, and then solve for x. So the x-intercept is not given to you by this, okay? And remember still, to find the y-intercept, you let x equal to 0. To find the x-intercept, you let the y equal to 0. A lot of you on the test, you mix them up. And you did find out eventually, you just put arrows, like this goes there, this goes there. That's good. So you didn't lose any marks, but some of you didn't find out until you just let it be like that. So y-intercept, x is equal to 0, x-intercept, y is equal to 0. Okay. So on this graph here, this point right here is called the x-intercept. Okay. This right here is called the y-intercept. And what's the slope of this particular line? Just by observation, no math. The slope of this line just find, like, these are 2 points on the line, right? So I'm going to use a red pen, and I'm going to travel to here, but I can't travel along the line. I have to go up and over, okay? So I'm going to go up, and I'm going to use blue to go over, okay? So horizontally, it took 2 units, and vertically, it took 4 units. So you always have to watch out for the scale that's on here, okay? So the slope would be 4, right, rise over run. And this is really just 2, right? And always remember, okay, don't forget this. Is it positive or negative? What is it? Well, from left to right, this thing is going up. So it should be positive, right? And think of it as 2 over 1. Think of it, when you see a whole number, put a 1 underneath, because if you look at this, you have a rise of 2 and a run of 1. So let's test that. Let's start back here. 2, 1, 2, 1. So you have a smaller staircase. This would be Mr. Dirksen going up the stairs, right, with my long legs. And this would be somebody else going up the stairs, right? It's the same. You're still going along the same slope, same steepness. It's just one goes faster than the other. But ultimately, they both reduce to the same slope, okay? And I should say positive. I'll just put a positive there so it kind of sticks, right? You don't have to do that on a test or anything, but in your notes, do that, okay? Let's go and graph these things, okay? So you're given an equation, and right now that's the only form we know, okay? If it's not looking like this, we might have to massage it a bit to get it to look like that, okay? But step 1, start with the y-intercept, b, okay? In this case, it is 0, and what is b? Remember, this is b, and that is m right there, okay? Because that's what you want to be looking at. It's like, what does this equation give me? Forget the y and the x, just look at the y-intercept is 0, 2. So we're going to go ahead and identify that. Just look at the 2. It's plus 2, so where is that? That would be right there. So make a big dot right there, a big mark right there. And then step 2, find more points using m, right? In this case, m is equal to 3 over 1. This is your rise, and this is your run. Okay, so we're going to use that to find our next point. So you start here, it's positive, right? So we're going to go 1, 2, 3. From here, you go 3 up over 1, and you make your point there. And you could keep going. You could go 3, 1, 3, 1. You could keep going, but you found another point right there. Technically, 2 points is all you need to draw your line, but sometimes we're going to ask you to find a third point. So imagine you went up the stairs, right? 3, 1. If you did the exact opposite, if you went down and back 1, you will line up with the same one, right? So we could say slope is equal to 3 over 1, or the slope is negative 3 over -1, right? That means that you're dropping 3 and you're going to the left 1. So from here where you started, down 3, back 1, right? Use a different color for this one. Okay. And then use your ruler, please use a ruler, and you connect those 3 dots. And because the equation is already there, we technically don't need to, but I just want you to get used to writing down the equation. On one of the ends, it doesn't matter where you do it, just make sure you have that. Okay. And from step 1, I will tell you to make an arrow just going to where you started, right? You always start with the y-intercept. And then you use the slope to find other points. Okay. So did you find other points? Absolutely. This would be -1, -1. I need you to understand that the slope will allow you to find more points, right? And this would be 1, 5. Right? You found 2 more points. Not only were you able to graph, you actually found more points on this line. Okay. All right. I think we're going to try a couple here. So we're going to graph these on the grids here. So we're going to use these two. How are we going to make this work? We're going to have to share. Anyways, you're going to have to share grids here, or else we won't be able to get it on there. So let's start with B here. My slope is -2, and B is equal to +1. Right? So the y-intercept is 0, 1. That's where you're going to start. And the slope will allow you to find, let's do this, -2 over 1. Let's put a 1 underneath if it's a whole number, right? So go find the 0, 1. It's right here. And now we're going to use our slope to find more points. And watch this, right? The negative always floats up. If the top number is negative, then you're actually going down 2 in this case over 1. There's that point, right? So I'm going to use red here. I went down 2 over 1. Let's repeat this case because you have enough grids still, right? Down 2 over 1. I just need you to know that you can find more than 2 points there. So there's your line, connect the dots, and write down y is equal to -2x plus 1 here. So you've identified that this is the one, okay? And by the way, just by looking at the slope, just by looking at it, you knew this line was going to go down because of the negative. Right? That negative told you that this line is going to be decreasing from left to right. Okay. And let's try C now. My slope is -1 over 2. And B is equal to 3, which tells me that it's 0, 3 where I'm going to start at. I'm also going to already make the observation that because this line is negative, I expect it to go down. Is it going to be steeper or less steep compared to this one? Shallower? Well, let's see by observation. We're going to graph them on the same grid so we can tell. Okay. So 0, 3 is right here. And then I'm going to go dropping 1. I'm going to use a different color for that one. I'm going to drop 1 and run 2. Drop 1 and run 2. Make a point there. And continue that one more time. Drop 1, run 2. You can tell that it won't be as steep as the other one. And then connect the lines, the dots. And I'm going to label it right here. Y is equal to negative 1 over 2x plus 3. See, in general, pay close attention to what I'm about to say. In general, I make the negative go up. See that? So that I only need to worry about the top. If this is negative, then I'm dropping, but I'm always running to the right. Because if the bottom number is positive, then you're running to the right. So then you only need to worry, is it going to go up or down, but I'm still always running to the right. And keep that in mind, okay? So this one here, my slope is 2/3. And b is equal to -5, right? So my starting point is going to be 0, -5. So that's your starting point. You start there. Okay? And then you use your slope to find you more points. So let's go 2 units up, 3 over. And then continue it one more time. 2 units up, 3 over. And here we have a bit more room, so you can say 2, 3, 2, 3, right? And graph your line. This is the line y is equal to 2/3 x minus 5. And then our special cases. This is just y is equal to a number. So it's going to be a horizontal line. Slope is equal to 0. This is x is equal to a number. It's going to be a vertical line. And here slope is undefined. I know I'm repeating myself quite a bit, but I've done this enough times where I thought I said it enough times and it still doesn't stick, right? So in this case, y is equal to -2. This statement is saying it all. Y is always equal to -2. So you go to -2, this is y is equal to -2, and then you just graph a horizontal line that goes through that point. Because now you're saying y is always equal to -2. Arrowheads, notice how I'm doing that? And then x is equal to 4. X is always equal to 4. That's what that statement is saying. So you go along the x, You find that point right there, x is equal to 4, and then you just graph your line vertically there. There you go. You have two slopes here. This one isn't rising at all. That's why slope is equal to 0. This one doesn't have a run. And so anything divided by 0 is always undefined, right? So there you have your two special cases. So again, start with your y-intercept and then use your slope from there. Unless you have the special cases, then it's either a vertical or a horizontal line. So we call these diagonal, or, right, you got your vertical and horizontal. If you have two variables in there, you know it's going to be a diagonal line, right? Y and x could be any two variables, by the way, but that's just how it is. So let's go to the next page here. So we're now going to go through different scenarios without necessarily getting a visual, okay? So we're told that a line has the equation y is equal to mx plus 6. So all you're given here is this, right? Find m if the line passes through 3, 2. It passes through 3, 2. So I will make a note here, no graph, calculate the slope. Okay. Here, how we have one point, but we need another point, and that's where you extract it. This right here, right, is the y-intercept, and that is 0, 6. And then you have 3, 2 as your other point. So right now you have 2 points, right? You can call this x1, y1, x2, y2. Because this equation is asking, hey, what's the slope? It's partially done. It's like, hey, I have a partial equation here, but I also know it goes through a second point here. So you extract the first point from the equation, knowing that this is your y-intercept, which is 0, 6. And then this is your second point. So now we can go ahead and find our slope. So it's 2 minus 6 over 3 minus 0. And that'd be negative 4 over 3. So this is the slope that you would need to have to make it through this point. Okay. Therefore, the equation is y is equal to negative 4 over 3 x plus 6. Unfortunately, yeah, we don't have enough room to actually graph it, but it would be neat to see, right? You would start with, let's imagine this is gone now. Let's graph this. You start at 6 and then you use this slope. You should go through this point. This point should be part of the line, okay, after doing that. Okay. So this is step, right? Step 1. You do this, right? And then we take this and insert it there. So always think about, what does this give me? Is this giving me something? Yes, right? It did give me partial information. Can I just add, I would like to add something. To be, what would the equation of a line perpendicular to A look like? Can you write that down, please? What would the equation of a line perpendicular to the line that we just found in A? We're going to make that A, right? What would it look like if you needed to come up with the equation of a line that's perpendicular to this line here? Well, this is how you would approach that. The slope of, we're just going to call this A like that. The slope of the equation in A was -4/3. Right? A slope that would be perpendicular to this one, you would change the sign and flip it. This is the slope that you would need to have. It doesn't matter what your y-intercept is. If you have a line with a slope of 3/4, it will meet this one at a 90°. Therefore, it would be y is equal to 3/4 x. And this you can fill in the blank. I'm going to use the same one as up there. Sorry. I'm going to use the same y-intercept as up there. That you can fill in the blank. You can do whatever you want there. But this equation, this one would be perpendicular to that one simply by looking at the slopes. All right. Hi there. Anywhere is fine. Yeah. Thank you. So this is an aside. This is drawing from the last section we just did. Okay. It's simply by looking at the slopes that you find out. Okay, so we'll do a couple here. Write an equation for a line with a slope of 5 and a y-intercept of -2. This is as basic as it gets. Slope is 5 and b is -2. That's what they're telling you. Therefore, the equation would just be y is equal to 5x minus 2. That's it. Okay, so your slope is there and the y-intercept is there. Just make sure you get your signs right. And it just keeps going the same way, right? Y is equal to -1/5, x, don't forget that, plus 5. Would these two be perpendicular? Are these negative reciprocals? Yes, right? You see it? If you were to take a slope that is perpendicular to this particular equation, you would have to change the sign of that slope and flip it. You get 5. So these two are perpendicular, right? Lines A and B are perpendicular. I'm making a note of that because I want you to start thinking about it as well. I know today is more just focusing on the slope-intercept form for you to get familiar with this form of the equation, but this is still always at play, right? How do you check if they're for sure perpendicular? You multiply them and you should get -1. If you multiply two slopes and you get -1, you know they're perpendicular. Some of you need to watch those videos, right? You want an equation that passes through 0, 1 and has a slope of 2/7. This particular point you should recognize y-intercept. Therefore, b is equal to 1. You just look at that second value, right? You know it's the y-intercept because x is equal to 0, right? X equals 0, you know it's the y-intercept. Therefore, y is equal to, I need my slope, and I need my y-intercept, just the y value, which is that. So this would be an equation that would satisfy that, the conditions there. D passes through the origin. What's the origin again? 0, 0. And this is something particular about this origin. It is the x-intercept and the y-intercept at the same time. So it's like, what? It's like, but let's just focus on the y-intercept. This is my y-intercept. B is equal to 0 here. I'm focusing on this. I know x is equal to 0. Therefore, I focus on that. So B is equal to 0. Slope is equal to -4. So my equation here would be y is equal to -4x plus 0. But we don't really do that, right? We don't really do that. So it's just, therefore, it's just y is equal to -4x. And I will just say omit. But you should know that if it's not there, that your y-intercept is 0, 0. Okay. It's going through the origin. Now it's a little bit tougher. Has the x-intercept of -3 and a y-intercept of 6. I already give you the hint. Find the slope first. You need a slope to come up with the equation. Need slope. So x-intercept can be written as -3, 0, right? And the y-intercept can be written as 0, 6. I will make this x1, y1, and this x2, y2. Slope is y2 minus y1, x2 minus x1. Rise and run. Change in vertical over change in horizontal. So it's 6 minus 0 over, get this right, it seems simple enough, but it's the signs that are going to cause you trouble, okay? x2 minus, this minus comes from the equation, the difference. x1 is actually -3, so you get a double negative there. So that's positive, right? So it's 6 over 3, which is 2. Therefore, y is equal to slope times x, and then my y-intercept is 6 plus 6. That's it. This is the equation of that particular line. What about the x-intercept, Mr. Dirksen? Doesn't that find its way miraculously into the equation? No. It just helped us to find the slope. And then when we had the slope, we inserted it there because remember, this is always the case, right? The slope-intercept should look like that. And this is the last section here on the graph. What's missing about these lines? Oh, they are there, arrowheads, but they're really small. So I don't, let's make sure we understand. I need to edit this file, make sure they're there. Don't forget the arrowheads. Write the equation to describe the following functions. And then we're going to verify. So we're doing the same thing. You know how we went from the equation and then graphed? We're going to find b first. B in this particular case is +3. Okay? My slope, what's your prediction? Positive or negative? Negative, right? It's going down from left to right. So I know it's going to be negative. And then we're going to come up with a rise and a run. So you just find another point that is right on the intersection. This is another one right here. Mr. Dirksen, could I like go on the other end of the line and do that? Yeah, you could. if you wanted to. I wouldn't recommend that. So we're going to go down and over. Okay. Our slope is 2 vertical units and 1 horizontal unit. I will just say this is the counting method. I just count, right? And you want to verify this way. Does it keep going the same way? Do I keep doing 2 and 1 and it stays on the line? And it is, right? So you are indeed looking at a negative 2 over 1. So the equation would be negative 2x plus 3. Okay. I will highlight the negative 2. It's basically 2 over 1. And then orange. Right? Let's keep going. B is equal to negative 2 here. Slope is equal to, how about this? We make a little sign for ourselves. This means it's going to be positive, right? So I don't have to worry about the negative. Let's go back here to the original one and just do one of these. You know it's going to be negative there. That's why I put the negative right at the beginning. Just put it in front, and then you just count the other ones. Okay. My slope here is supposed to be positive, so let's scan the line. Not a good point. Not a good point. This is a good point right there. If you kept scanning, the next one would be here. Right. So you just basically now, it's always up or down first, and then over. So this, and then this, and this, right? So it's consistently the same. So it's 3, 2, 3, 2. So I know that my rise is 3 and my run is 2. Therefore, the equation of this particular line would be 3 over 2x minus 2. Here, you always focus on where does it cross the y-axis, right? So b in this case is 0. My slope, I know this is going up, right? From left to right is going up, so I'm expecting a positive slope. Scan the line. There's another point right there. That's a good one. So it's up and over. So there's one vertical change, 1 unit of vertical change, and 4 of horizontal. So my rise is 1, my run is 4. Therefore, my equation is 1 over 4x plus 0. Well, we'll just omit it, right? And maybe I'll just do the highlighting one more time, right? 3 over 2 is there. That's where the slope goes. 1 over 4 is there. That's where the slope goes. The -2 goes here, and the 0 is back here technically, right? But we're not gonna, it's just, I will mark it wrong if you do. If you go +0, it's fine, but we don't normally do that. All right, homework. There are word problems at the end, but I'm gonna wait for now. Maybe a little bit of that would be okay. 362, 4 to 6, just A and C. That way you don't need to do all of it, just A and C for all of those. 7, A to D, 8 to 9, and now the word problems, I think. Sure. 62, 8 to 9, 10, no, not 10. 12, 14, and 50. Okay. There are some word problems in there. It should make sense. It's kind of like you get paid this much per hour plus a fixed rate of this. We did talk about it in chapter 5. Just give that a try, okay?